Part 2. Coming back to this idea of solar insolation. You've already been introduced to this idea of solar insolation, or the amount of sun's energy reaching Earth on a surface over a period of time. In other words, it's Earth's exposure to the sun's rays per unit area over this time frame. And this is different from solar radiation, which is the sun's electromagnetic solar radiation consisting of UV rays, infrared rays, X-rays, etc. We also know that solar insolation is affected by factors such as the atmosphere, the angle of the sun, and distance away from the sun. And I want to re-quote this sentence that Max stated last lecture. Seasonal and latitudinal variations in temperature are driven by variations in insolation. This graph hopefully looks familiar. It's taken from our solar insolation spreadsheet, and it shows the incoming insolation in watts per square meter over the course of the day. And we can see that insolation varies and that this makes sense. As we approach solar noon, the angle of the sun in the sky increases, and we see that incoming insolation increases. In this diagram, it increases up to about 900 watts per meter squared. In the afternoon, as we move further away from solar noon, the angle of the sun in the sky decreases as the sun sets, and we see insolation decreasing. Now, it's important to note that at the upper atmosphere, the energy density of solar radiation is around 1,360 watts per square meter. And at Earth's surface, energy density is reduced. It's also important to note that Woodstock is located at a latitude of 43.6 degrees. And if you refer back to our earlier lecture from Max, you'll know that the amount of insolation varies with latitude. So if you've played around in the Google spreadsheet, some of you have already done this. You can change the date by clicking on cell D3. And as you explore, you can discover that insolation varies across larger timescales, such as over several months. And I played around with changing the date, and here I've copied and pasted the graphs of the spreadsheet generated on the 10th day of every month from March to July. I chose these dates arbitrarily, and I chose them because I wanted you to see that in these graphs, as we progress from month to month, we can begin to see some trends in the data. And I'm challenging you to explore parts of your own spreadsheet to answer these questions. During which month is incoming insolation greatest? During which month is solar altitude greatest? What trends do you notice with seasonality? For example, as we move from spring to summer. And how does this fit with what you've learned in earlier classes? So play with changing the dates, notice how solar altitude and incoming insolation varies, and tomorrow be prepared to share out your findings. What trends did you recognize in altitude or incoming insolation? Were these trends daily or seasonal? And over what time scale did you observe these variations? Finally, can you expand your thinking to consider an additional variable, such as latitude, and how that might change insolation? The purpose of this playing around in the spreadsheet is to explore potential trends that you can find in the data, and hopefully it'll get you thinking about what additional trends you might be able to convey. And later in the week, you'll be challenged to expand your thinking to explore trends resulting from different latitudes, varying cloud cover, albedo, topography, or atmospheric composition. Thanks so much.